Welcome to this explainer. Today, we're looking at a super elegant solution to one of those everyday development headaches. You know the ones. We're pulling our insights directly from Eng's Notes on Haskell Programming, specifically a really interesting post from May 21st, 2026. We're going to explore this concept of declarative cleanup via temporary directories in Haskell testing. It's honestly wild how just a tiny shift in how we handle files can literally transform the resilience of your entire test suite. Okay, so let's dive right into this. Picture this. You're working on a cool new feature, you run your integration test, and boom, the suite passes green. You're feeling great, right? But then you open your File Explorer or your terminal, and your project root is just completely littered with leftover generated junk files. What actually happens when your integration tests leave these lingering artifacts behind? Well, it's a super frustrating reality for a lot of developers, and it's exactly the situation where our source material kicks off today. Which brings us to Section 1, the lingering file problem. And Section 2 explores the knee-jerk reaction we all have to that clutter, the manual workaround. Now, this perfectly illustrates what the author calls imperative testing. Just look at the sequence. Let's say you're building tests for an ebook converter. You decide, hey, I'm going to use actual integration testing instead of just mocking the results. Sounds good in theory, but here's what happens. Step 1, the system generates a test artifact. In this case, an actual physical PDF file just sitting right there in your project root. Step 2, you run the test to check your assertions. All good. But then Step 3 hits. Because you didn't mock the output, you now have to write out explicit instructions to manually delete that PDF, just so it doesn't totally pollute the next test run. As a developer, you're literally spelling out every single manual action, creation, deletion, the whole shebang. You're basically micromanaging the file system environment instead of just checking if your ebook converter, actually works. Moving on to Section 3, the temporary directory solution. During a recent refactor, the author had a bit of a light bulb moment. They realized that constantly fighting to delete these test artifacts was just totally unnecessary overhead. Instead of obsessing over deleting them, why not just change where the files live in the first place? They decided to let the program generate these artifacts directly inside the operating system's native temporary directory rather than the project root. And honestly, the impact of this seemingly tiny shift on the whole testing workflow is a real game changer. By routing it output to the temp directory, it instantly keeps your project workspace absolutely spotless. No more clutter. Second, it completely eliminates the need for any manual file cleanup, because the OS itself is already designed to handle the lifecycle of its temp folders. And ultimately, as the author points out, it makes the test code so much cleaner and way more resilient. You're no longer stressing about some leftover state breaking your next run, or accidentally committing test junk to your version control. Now, I want you to notice the sheer simplicity of how this is actually executed in Haskell. It's brilliant. This single line of code, tmpdir equals run io get temporary directory, literally enacts the entire transformation. By just fetching the temporary directory path through run io, the author simply binds that path right into their test arguments. So, for example, they can set the input path to combine this tmpdir with their test text file. From there, they just describe their convert to ebook function, assert that it makes a physical PDF, and return the correct path. With just a handful of keystrokes, all that heavy lifting of state management is elegantly handed off to the operating system. Which leads us to Section 4, imperative versus declarative testing. You see, this isn't just some neat little directory meser trick. It actually highlights a much broader coding philosophy from the source material. It's the evolution from imperative to declarative testing. Let's put these two side by side. On one hand, we've got imperative testing. This is where you're totally bogged down in the weeds, the manual steps of file creation, state mutation, and file deletion. It's step-by-step micromanagement. On the flip side, declarative testing simply states what the expected result is. That's it. The temporary directory solution bridges this gap beautifully. It takes your test suite away from those messy, manual chores and turns it into clean, automated code, where you literally only care about what the converter spits out. To formalize this a bit based on the author's notes, declarative testing is a testing paradigm that focuses purely on stating the expected result, rather than dictating the manual steps required to manage the environment. By embracing this declarative style, the author found that their test codes became incredibly clean. It's like a breath of fresh air. The test suite does exactly what it's supposed to do: verify the business logic without getting tangled up in the annoying mechanics of setup and tear down. So, this brings us to a final thought for you to take away from today's explainer. I want you to take a hard look at your own codebase. What do your habits look like? Are your integration tests truly resilient and declarative, or are you still stuck playing janitor, manually cleaning up artifacts after every single run? The next time you catch yourself writing some tedious teardown script for file artifacts,
Keep the straightforward Haskell approach in mind. Just ask yourself, couldn't the operating system be doing all this dirty work for me? Thanks so much for joining me for this explainer, and hey, happy testing!